This is Precalculus class notes, section 1.2, review of basics of functions and their graphs. And I'm going to be going over the 4 examples for this. Again, please read over the learning objectives. Make sure you've read through the e-text as well. So in the first example, we want to find f of x plus 2 if the function f of x is equal to minus x squared plus 2x plus 5. And similarly, in the second example, we want to find f of g of 2 if f of x is this function and g of x is this function. So let's go to page 5 and review how to do these things. So first of all, in the first example, f of x is minus x squared plus 2x plus 5. So if we want to evaluate f of x plus 2, that means to take this quantity, x plus 2, and plug it in for x into the original function f of x everywhere I see an x. So that means f of x plus 2 would be minus the quantity x plus 2 squared, plugging it in for this x, plus 2 times the quantity x plus 2 plus 5. Then it just becomes a matter of simply simplifying it. So you have to FOIL the x plus 2 to get x squared plus 4x plus 4. Bring all the like terms together, and you finally get that f of x plus 2 is equal to minus x squared minus 2x plus 5. In the second example, we had f of x equals x squared plus 3x minus 2, and g of x, another function, is 2x minus 6. So if I want to find f of g of 2, we always work from the inside out. This is called a composition of functions. So first of all, we'll find g of 2. G of 2 means you take 2 and you plug it in for x into the function g of x. So g of 2 is 2 times 2 minus 6, or minus 2. Thus, f of g of 2, now that we know that g of 2 is minus 2, I plug that in here for g of 2. That's equal then to f of minus 2, which means I now take minus 2 and plug it into f of x everywhere I see an x. So that's minus 2 quantity squared plus 3 times minus 2 minus 2. After simplifying, you see that f of g of 2 is minus 4. Okay. In our third example here in section 1.2, we want to use the graph to determine A, the function's domain, B, the function's range, C, the x-intercepts, if any, and D, the y-intercepts, if any. So the domain of the function, domain of any function, is all possible x values. And when you're not given a set domain, you just have to look at it and say, well, what possible x values, work for this function? And we can see here when we see a function graph like this, that it goes down like this, and that arrow means it's just going to keep going this way forever. Likewise, this arrow means it's going to keep going this way forever. So no matter what value of x I were to have, there would be a value on the function. So the domain for this function is minus infinity to infinity, or all x, all real values, all real numbers for x. The range, however, is what are the possible y values of the function? So you have to think about as x goes over its entire range, what are the values that y ranges over? Thus the word range. So the possible y values, these arrows both go down like this. So you can see that as y gets more and more negative, these arrows are shooting down towards negative infinity. So y will range from negative infinity all the way up to this value right here, and that's the largest y will ever become. So that is actually y equals 0. So the range is minus infinity to 0, with a square bracket around 0 because 0 is actually included in the range. If this came up and didn't quite touch, there was an open dot here, that would be an open parentheses, which would mean don't include 0. But here we are including 0. The y-intercepts are where does it cross the y-axis? So here's the origin right here. So it crosses the y-axis right here at y equals minus 1. Okay. The x-intercept, notice I didn't write it on here, but the x-intercept is this value. It touches the x-axis right here at x equals 1. It's the only place we touch the x-axis. This is the only place we touch or cross the y-axis. And then the last example is if I have a function like this is called a rational function, where I have a polynomial divided by a polynomial. A little more complicated than just a polynomial, but similar. If f of x equals this guy, let's find f of minus 3. Again, that just means take in minus 3 and plug it into x. Now, you could have left the function like this, and you would have had more complicated work to do, but this is the one that we could simplify. Notice when I have something plus something else, or a plus b divided by c, I could have a divided by c plus b divided by c. So I have 3x cubed divided by x cubed just becomes 3, and 2x divided by x cubed becomes 2 divided by x squared. So now I just have to plug in minus 3 in for that value of x, and that simplifies to 29/9.